Okay, hello. This is a presentation about solving Wi-Fi congestions in dense areas. My name is James.
My name's Yvette.
And my name is Riley. Today we're going to be focusing on congestion, slowdowns, issues caused by dense, very packed networks, and what you can do to mitigate them.
So, solving Wi-Fi congestion in dense areas. This presentation explores the challenges of Wi-Fi congestion in densely populated areas and presents effective solutions. We will delve into technologies, best practices that can elevate these issues supported by research findings. These congestion occurs when multiple devices compete for limited wireless resources, leading to slower speeds, increased packet loss. This phenomenon is particularly prevalent in high density areas where numerous devices are connected simultaneously. And what exactly is Wi-Fi congestion? So, it is defined as the degradation of network performance due to an overload of devices accessing the same wireless channel at the same time, which then occur by giving the results of slower internet speeds. Um, so, congestion control strategies. Basic control strategies like carrier sense, multiple access with collision avoidance, and a traffic shaping are essential for managing network traffic. These methods can help prioritize data packets and reduce the likelihoods of collisions, ensuring smoother communication and Wi-Fi networks. Studies indicate that traditional congestion control methods are becoming less effective in high-density Wi-Fi environments. The SIGCOM paper highlights the need for innovative approaches to address unique challenges posed by modern wireless networks.
Dynamic frequency selection, or DFS, let Wi-Fi routers automatically change channels to avoid interference from radar and other devices. This helps keep performance strong, especially in crowded areas with lots of networks. What is DFS? DFS help routers detect radar signals and switch channels to avoid interference. It's important in busy areas where many devices are fighting for bandwidth because it keeps the network more stable and reliable. Best practices for DFS. For DFS to work well, a router should be set to quickly detect radar signals and automatically switch channels, instead of relying on manual settings. Letting routers adjust on their own really helps improve network reliability, especially in crowded areas. Why DFS matters in congested areas. In crowded areas, DFS help Wi-Fi networks move away from busy frequencies. This leads to faster speed, lower delays, and better overall user experience, especially when lots of devices are connected.
Today we'll talk about how to use DFS channels in Wi-Fi. DFS means dynamic frequency selection and is a Wi-Fi function that enables WLAN to use 5 GHz frequencies that are generally reserved for radars. One main benefit of using DFS channels is to utilize under-service frequencies to increase the number of available Wi-Fi channels. If you're planning to use DFS channels, you first have to verify that both your Wi-Fi access points and wireless clients support these functionalities. The following table lists the Wi-Fi frequencies in use for the 5 GHz band, including the ones reserved for DFS channels. Let's talk about DFS channel availability check. It will be necessary for Wi-Fi access points to verify that any radar in proximity is not using DFS frequencies. This process is called channel availability check, and it's executed during the boot process of an access point, as well as during its normal operations. If the IP detects that a radar is using a particular DFS channel, then it will exclude that channel from the list of available channels. This state will last for 30 minutes, after which the IP will check again if the channel can be used for Wi-Fi transmissions. The channel availability check performed during the boot process can take anywhere between 1 to 10 minutes depending on the country which you're in. For this reason, DFS channels are not immediately available when an IP boots. If an IP detects during normal operations that a radar is using a particular channel that is currently in use, then it might communicate to associated Wi-Fi clients to stop transmitting on that channel. The IP will then switch to another available DFS channel within the channel move time, which is generally set to 10 seconds. This behavior will cause connected Wi-Fi clients to be disconnected from the network for a period of time before reconnected to a different channel. It's very important to keep this behavior in mind when enabling DFS function, because Wi-Fi networks that are servicing real-time and mission-critical applications might want to avoid such disconnections caused by DFS frequencies. I hope this brief guide was beneficial to learn more.
And now we'll be diving into channel section, selection, and future directions. Choosing the right channel. Selecting the right Wi-Fi channels is crucial for minimizing interference and maximizing network performance. By analyzing the surrounding environment, users can identify the least congested channels for optimal connectivity. Um, the importance of choosing the cleanest channel cannot be overstated, as it directly impacts the quality of the Wi-Fi signal. Research from Santa Clara University emphasizes the need for systematic channel analysis to avoid interference. In recent studies, it's been introduced that advanced algorithms that utilize machine learning for real-time channel selection. These innovations allow network um, adapt dynamically to changing conditions, enhancing overall performance. The practical recommendations to ensure optimal performance, it is recommended to use routers that support automatic channel optimization. Additionally, checking for dynamic frequency selection capability can further enhance the network efficiency.
Rules and real-world deployment. Understanding the regulatory landscape is essential for effective Wi-Fi deployment in congested areas. Compliance with regulations ensure that devices operate without causing interference to one another. Regulatory role in Wi-Fi congestion. Regulatory bodies like the FCC play a crucial role in managing Wi-Fi congestion by establishing guidelines for device operation. These regulations help mitigate interference and promote fair usage of the spectrum.
And implementing dynamic frequency selection is essential for compliance with regulatory requirements. This technology enables routers to detect radar signals and switch channels to avoid interference, ensuring reliable connectivity. For future directions, the Wi-Fi technology lies in stricter compliance and development of smart devices that can adapt to their environment. Innovations in AI and machine learning will further enhance channel selection and overall network performance. And of course, moving forward towards smarter Wi-Fi, as a number of devices continue to grow, addressing Wi-Fi congestion will become increasingly important. Embracing technologies like DFS and smart channel selection will be key to achieving healthier Wi-Fi connections.
And here's the list of all articles that we used, all citations, so on and so forth. And we will leave you with two questions. With the knowledge you have of modern Wi-Fi standards, how would you address congestion apart from DFS? And do you think DFS is a strong compromise between radar frequency utilization and Wi-Fi frequency utilization? Why or why not? Thank you.